Welcome everyone. Through this video, I am going to discuss derivative of functional relation, part 2. Today, I will deduce a most important result of functional relation. Using this relation, we can solve many problems. So, what is the relation? If f nx plus my by m plus n equals to m into f1, n into fx by m plus n, then f is linear function. This is most important result. F nx plus my by m plus n equals to m into fy, n into fx by m plus n, then fx is linear function. So we need this result. Now look the proof of the result. So this is x-axis, this is y-axis, and y equals to fx is any curve. So if it is x, then since function is fx, so this is fx. So what is coordinate of a? X comma fx. When is y? So coordinate of b is y comma fy. Let P is any point on the curve. Draw PR perpendicular to x-axis. Now Q is a point. Suppose it divides AB in the ratio m is to n. So what is coordinate of R? That is x coordinate. So this is x and this is y. So ratio is m into n. So x coordinate of R is m into y, m into y, n into x by m plus n. This is x coordinate of R. Now y coordinate, so this is fx, so n into fx, m into fy by m plus n. So this is coordinate of q. Now from graph, so coordinate of r is same. So this is abscissa for both p and q. So what is coordinate of p? So nx plus my by m plus n. This is coordinate of x coordinate of p. So what is y coordinate? Y coordinate. So x is replaced by, so y coordinate is x is replaced by, so this y coordinate will be f into my plus nx by m plus n. So this is y coordinate because it is function is fx. If we put x, we get y. Now from graph, look, this is PR. PR greater than QR. So PR greater than QR. So what is PR? Graph of y. That is f of my plus nx by m plus n greater than, what is QR? QR is y coordinate of q. So this is m into fy, n into fx by m plus n. So from figure we are getting this relation. Now according to condition, so it is given that m nx plus my by m plus n equals to m into fy, n into fx by m plus n. So this is our functional relation. So this is our given functional relation. So this is possible when P and Q coincides. So this is possible when P coincides with Q. That is P coincides with Q. That is P coincides with Q. So A, P, B are collinear. That is f is linear function. So fx equals to ax plus b. Fx equals to ax plus b. So we need this result only. So these are all problems from Cengage publication. So look, problem number 1. Again you look the result. F nx plus my by m plus n, m into fy, n into fx by m plus n, then fx is linear functions. So we need this result. So proof, we have already given it. AB, y equals to fx is a curve A, coordinate of A. If it is x fy. This is n. If it is y, then it is y fy. So Q divides it. AB, so PR drawn perpendicular. So this one is Q. Let Q divides AB in the ratio m is to n. M is to n. So what is x coordinate? Nx plus my by n, and this is y coordinate. Now since y equals to fx, P lies on y equals to fx. So coordinate of Q will be x coordinate same, but y coordinate is this. So from figure, PR greater than QR. So PR is this, QR is this. Now from the given condition, this is our given relation. So this is possible when P coincides with Q. That is A, P, B are collinear. So f is a linear function. So it is of the form fx equals to ax plus b. So we remember this result. So application of this result. Now we consider some application of the above result. Now problem number 1. So f satisfies x plus 2y by 3 fx 2 into fy by 3. So we can write it as f 1 into x 2 into y by 1 plus 2 equals to 1 into fx 2 into fy by 1 plus 2. So, look, this ratio is 1 is to 2. So, we have already discussed. So, if we get y equals to fx, so this is A and this is B. Then this divides 1 into 2, that is 2 is to 1. It divides 2 is to 1. 2 is to 1. So this relation, so M, this is P, this is M. We have already discussed it. So f 1 into x, 2 into y, 1 plus 2. So this is internal bisect. So section formula. So we can say that fx is linear function. Linear function. So P divides AB. Here P divides AB in the ratio 2 is to 1. So A, P, B are collinear. So fx is a linear function. So if fx is a linear function, so we can write fx equals to ax plus b. Now, if fx is linear function, there are two constants a and b. So, use initial condition. So, f0 equals to 2 implies 2 equals to b. X equals to 0. So, what is f dash x? F dash x equals to a. F dash x equals to a. Now, what is f dash 0? F dash 0 equals to 1 implies 1 equals to a. So, we are getting a and b. So, what is fx? Fx equals to x plus 2. Fx equals to x plus 2. So, application of the previous result. So, we can write fx directly. If fx is linear function, then use condition. So, similarly, look for problem number 3. For problem number 3. So, this is given relation f 2 into x 3 into y by 2 plus 3. We can write it as 2 into fx 3 into fy by 2 plus 3. So 2 into fx. So it is 3 and it is 2. 2 into fx. This is x. So x fx. So 2 into fx. This is y. 3 into fy. So p divides. P and m coincides. We have already discussed it. P divides ab in the ratio 3 is to 2. So APB are collinear. APB are collinear. So fx is linear function. Fx equals to ax plus b. Now, using this condition, we can find a and b in terms of p and q. But look, here f double dash 0 is needed. So, since f is linear function, no need of using these two conditions. So, you know f dash x equals to a or f double dash x equals to 0. So, for any value of x, it is 0 because fx is linear function. So, look, most interesting result. Now, problem number 2. Problem number 2. So f satisfies this relation. So f of 5 into x minus 3 into y by 2 we can write as 5 into 5 minus 3. So it is 5 into fx minus 3 into fy by 5 minus 3. So here division is external. So P divides AB externally in the ratio 3:5. So 3:5. So P divides AB in the ratio 3:5. 3:5 externally. So fx is linear function. So what is fx? Fx equals to ax plus b. Now use initial condition. f0 equals to 3 implies b equals to 3. So what is f dash x? F dash x equals to a. Now what is f dash 0? F dash 0 equals to a equals to 2. So we are getting form of fx. So what is fx? Form of fx is fx equals to 2x plus 3. So this is fx. Now what is sin fx? Sin fx equals to sin of 2x plus 3. Now we need period of sin fx. So period of sin fx equals to 2 pi by coefficient of x. So period is obviously pi. So what is our relation? Sin ax plus b if fx equals to sin ax plus b. So period is 2 pi by a. So here a is replaced by 2. So this is pi. So these are most interesting problem if you know the general theory. Now we consider two more problems. Derivative of functional relation. Problem number 4. So relation is if x plus y by 3, 1 by 3, 2 fx, fy. So as before, we differentiate with respect to x, y as constant. So f dash x plus y by 3 into 1 by 3. 1 by 3 unchanged, 0 plus f dash x. This is constant. So 1 by 3 cancel out. Now we have already stated. We see the answer. So f dash 2 is given. F dash 2 is 2. So f dash 2 is 2. We have to find fx. So putting x equals to 2. X equals to 2. And what is y? Y equals to, if we put y equals to, this is f dash 2 we are getting. So this is 2 plus y. So this will be 2 plus y by 3. Now to get it, f dash x. So what is y? Y equals to 3x minus 2. So we want to get here f dash x or f dash y. So single argument. So obviously you have to put x equals to 2. If it is 2, then x plus 2 plus y. Now 2 plus y will be fy. So putting y equals to 3x minus 2 and x equals to 2. So what is x plus y? 3x by 3. So we are getting f dash x. So 2 cancel, f dash x equals to f dash 2. Now f dash 2 is given. So this is 2. So integrating fx equals to 2x plus c. Fx equals to 2x plus c. Now we have to use initial condition. So if we put x equals to y equals to 0 to the given relation, we are getting this is f0, this is 1 by 3, 2, this is f0, this is f0. So 3f0 equals to 2 plus 2f0. So we are getting f0 equals to 2. So f0 equals to 2 implies 2 equals to 2 into 0 plus c. So c equals to 2. So what is form of fx? So fx equals to 2x plus 2. So fx is 2x plus 2. Look again. We have already solved many problems using differentiation in the previous video. So differentiating, we are getting this relation. Now f dash 2 is given, that is why we are putting x equals to 2. And now to get it in terms of single variable, y equals to 3x minus 2. So we are getting f dash x. From f dash x we get fx. Now problem number 5. Relation is fx plus y equals to fx, fy, x square y, y square x. So differentiating f dash x plus y. This is f dash x. This is 0, 2xy, y square into 1. We are getting this. Now see the restriction. Now if we put x equals to 0 and y equals to 0 again, so f0 equals to f0, f0, 0, 0. So f0 equals to 0. We are getting one condition, that is f0 equals to 0. Now one more condition is given. So what is the second condition? Limit extends to 0, fx by x equals to 1. So f0 is 0, 0 by 0 form. So using L'Hospital rule, f dash x by 1 equals to 1. So f dash 0 equals to 1. So f dash 0 equals to 1. So now this is 2. If we take this is 2, this is 1. F dash 0 is given. So putting x equals to 0. Putting x equals to 0. And we need f dash 3. Y equals to 3 in 2. So what we are getting? F dash 3 equals to f dash 0 plus 2 into 0 into 3 y, so 3 square into 1. So f dash 3. What is f dash 0? F dash 0, so this is 1. 1 plus 9 equals to 10. So what is f dash 0? f dash 0 equals to l. So very simple problem if we use this method. Now we consider two more problems. So problem number 6. The graph of fx is symmetric about 5, 0. Symmetric about 5, 0 and f dash 7 equals to 3. Then find f dash 3. So symmetric about 5. So since it is symmetric about 5, 0, therefore f of 5 plus x equals to minus f of 5 minus x. So look, if we know it is symmetric about origin, then it is odd function. So if we put 5 equals to 0, so it is replaced by minus 5. So f of x equals to minus f of minus x. It is symmetric about origin. So this is symmetric about origin. So symmetric about 5, 0. So this is definition. If a function is symmetric about 5, 0, then f of 5 plus x equals to minus f 5 minus x. Now differentiate f dash 5 plus x into 1, f dash 5 minus x into minus 1. So f dash 5 plus x equals to f dash 5 minus x. So we need this definition, symmetric about 5, 0. Now f dash 7 is given. So to get f dash 7, x equals to 2. So what is f dash 7 equals to f dash 3. Now f dash 3, f dash 7 equals to given 3. So this is 3 equals to f dash 3. So f dash 3 equals to 3. So functional relation is not given directly. It is symmetric about 5, 0. About 5, 0. If it is a, then a plus x minus f a minus x. Now problem number 7. Same type problem. So graph of y equals to fx is symmetric about y-axis. Symmetric about y. So suppose x square equals to y. This is parabola. So if we replace x by minus x, then equation is not changed. So it is symmetric about y-axis. So if we replace x by minus x, no change. So since fx is symmetric about y-axis, so f of minus x equals to fx. No change. F of minus x equals to fx. Even function, that is, it is even function. And gx is symmetric about origin. Gx is symmetric. We have already discussed it. Symmetric about origin. So gx is odd function. G of minus x equals to minus gx. So these are our two conditions. Now hx equals to fx into gx. Fx into gx. So this is even function, this is odd function. So finally you know it is odd function. So odd function minus h of minus x. Product of even and odd is odd function. So if it is odd function, h of minus x equals to minus hx. Then differentiate. So what is differentiation? Look, after this step, h dash x equals to h dash minus x. H dash x, h dash minus x, and this minus plus. So h double dash x, h double dash minus x with minus. So h triple dash x, h triple dash minus x, minus plus. So it is at x equals to 0. So h triple dash 0 equals to h triple dash 0. So both are same. So what will be our answer? It is not 0, it is not h00, so cannot be determined. Both are positive. So you cannot find. So triple derivative of hx cannot be determined. So this is also functional relation, but relation is not given. Symmetric about y-axis, this is even function. Symmetric about origin, it is odd function. So product of even and odd, this is odd, so minus hx. Then take 3 times derivative, put x equals to 0. We are not getting any. But if what is h double dash 0, h double dash 0 is 0. So h double dash 0 equals to 0. If you transfer to left hand side, this will be 0. So through this video today I have solved some important problems of functional relations. So these are most important problem for competitive exam. Thank you for today.